vector for u is going to be equal to 4 times 3, 12. I want you to see that the parentheses, they look like inequality signs, vector parentheses. Don't forget, don't use ordinary parentheses. 4 multiplied -1 is -4. Therefore, this vector represents vector for u. Anytime I'm told to find the dot product, it's really easy. So I am going to find a dot product here, so you see. So vector for u multiply vector v, and vector v is 3, 1. So see all these vectors. So vector v is 3.1 or 3, 1. So when I'm doing dot product, I'm actually going to take this one away and put a vector v there. All right. And so this is 3, 1. That's my vector v. Okay, so when the dot product is a scalar. Dot product is a scalar. In other words, it's just a quantity. 12 multiplied 3, 12 multiplied 3, okay, plus -4 multiply 1, -4 multiply 1. You see, I'm adding them. Okay, so whenever I'm doing a dot product, it's ordinary multiplication. I multiply the first by the first, the second by the second. And when I finish, I'll add them up. 12 times 3 is 36, plus -4. 36 minus 4 is 32. Therefore, vector for u dot vector v is equal to 32, a scalar quantity. A scalar quantity has only magnitude. The dot product has magnitude. All right, so evaluate that, and that's all they want me to do. They just put this one for, so we have to be careful. They gave me v. I don't know why they put w there. There was no use for w. So we will not now. I want to make sure we get here. Let's make sure we get to vectors first. All right, so we are doing the addition and subtraction of vectors for now. So this is number 6. I think that's the next one to do. I'm given vector u and vector v. Find a 4 times u. So if I'm looking for 4 times u, the same way we did the other one, vector 4 times u is something as 4 outside. Remember, the parentheses should be, they look like an equality sign. Okay, so this 4 is outside, and then my vector u is 6, 4. Remember, that's a comma here. Okay, so that's all, and then I'll multiply that. So I'm told to find 4 multiply vector u. All right, so 4 times 6 is 24. Remember, it is still a vector. The product of a vector with a constant is still a vector. 4 times 4 is 16. So if I multiply a vector by a constant, my answer is still a vector. So this is 24 and this is 16. See, there's a vector parenthesis here. Okay, so 4u plus 2u. I already have 4u here, plus 2v. So all I need to do now is get 2v. 2v is going to be 2 outside. I get v down. Where is v? v is 2, 0. I multiply that out. So 2 times 2 is 4. 2 times 0 is 0. So I have It's still going to be a vector. Scalar, I mean, a scalar multiplying a vector will still be a vector. So 4, 0. 4, 0. Okay. All right. So I am told to add vector 4u plus vector 2u. Well, I still have my vector 4u. So I am told to add these two quantity right here. 24 plus 4 is 28. I'm adding two vectors. My answer is still going to be a vector. 28. And 16 plus 0 is 16. And so on. If you're told to subtract vectors, no problem. You can subtract it. So let me bring down vector v, subtract vector 2u. So vector v is still 0. And I'm going to subtract vector 2u. And vector 2u is going to, let me just put it down first. Okay. And then the next thing I want to do is simplify vector 2u. So 2 times 6 is 12. So I have 2, 0. It's a vector, don't forget. Minus here, 12, remember, 2 times 4 is 8. And I am subtracting. So I subtract the first component with the second. So 2 minus 12 is negative 10. 0 minus 8 is negative 8. Therefore, vector v minus 2u is negative 10, negative 8. I put it in here, negative 10, negative 8. Okay. Okay, so this is it's not that bad. Okay, I can also be given a vector in like a array. Vector like a array, because remember that a vector has magnitude and direction. So this vector is in the first quadrant. The vector is in the first quadrant. Write the vector in the form AB. First of all, if the vector is in the first quadrant, I can find the vector in, first of all, let me find this vector in trig form, trigonometric form of a vector, trigonometric metric form of a vector. So the metric form. All right. So I just want us to remember that in a unit circle, any point is cosine theta, sine theta. That's one thing we can remember right now. So any point is cosine theta, sine theta. So this vector is stopping here. That is the terminal. The beginning is the initial. And this angle given to me is 25 degrees. 25, not 55, 25 degrees. So that angle is 25 degrees. The magnitude of that vector is 4. I can be told to write this vector in trigonometric form. So without wasting time, this coordinate here is cosine sine. So remember in trigonometric, in vectors, you also use unit circle. So now let me write this vector in. So this vector in trig form is 4 cosine 25 degrees and 4 sine 25 degrees. So I have written the vector in trig form, but they didn't want me to write my answer in trig form. So first of all, you call this one the horizontal component. Horizontal component of the vector is this, and this is the vertical component, which means if you complete a right triangle here, the vertical component is y-axis. The horizontal component is the x-axis. Now, if I'm told to write this vector in, of course, I'm told to write it in component form. So I'm going to write the vector in component form. Let me see. And they told me to leave my answer to the nearest thousand, to 3 decimal places. It means I have to use my calculator. So before I start doing this, I have to go to mode first, because they give me the degree in, they give me the vector in degree. The angle is in degree. So I go to mode. You cannot forget this, and make sure that the mode is in degree. Okay, and then you can go ahead and multiply. To find the horizontal component of the vector, 4 multiply cosine of 25 degrees, close parentheses, enter, leave your answer to 3 decimal places. Therefore, the horizontal component of the vector is 3.625. Okay, so that is 3.625. Likewise, the vertical component is the y. So 4 multiply sine 25 degrees. So I'm going to get, no problem, this vector is actually in the first quadrant, so I don't have to worry about all students take calculus, because all 3 ratios are positive in the second quadrant. Very soon now we shall get to the vector that is in another quadrant, and we shall deal with that. So I'm going to multiply to get the vertical component. 4 multiply sine 25 degrees. Don't forget, the mode must be in degree, because the answer question given to you is in degree. My answer to 3 decimal places is 1.690. Therefore, the vertical component of the vector is 1.690. 1.690. So I have both the vertical component and horizontal component. I have both the vertical and horizontal component. And see, don't forget your vector parentheses. Okay, I'm coming to parallelogram rule. Let's do more resolution of vectors. Okay, let's go back. Let's see more, and then I'll come back here. I am going to come back and do one more of vectors that are, okay. Number 15, we just did one like number 15. So I'm told to find the vector here. Again, I find the horizontal component and I find the vertical component. So I'm told to leave them in ordinary form, component form. So I have 4 multiplied by cosine of 45 degrees and 4 multiplied by sine of 45 degrees. Cosine of 45 degrees is √2/2. Okay, so remember in this one, I'm told to leave my answer including radicals. All right, so you have to be careful. This question says leave your answer in form of radicals. So you're using special right triangles. And so I have 4 √2/2, comma 4 √2/2. Divide by 2, I have 2 √2 and 2 √2. The vector is in the first quadrant, so I don't have to worry about the sign. So that is the component form of that vector. That is the component form of the vector. I'm not sure that I'm recording this. Let me make sure that I'm recording it. Let me go back. Okay, I'm recording it. All right, so let's go back and do one more vector in coordinates. Degrees minus 4 sine of 25 degrees. I see that because this angle, The reference angle is 25 degrees. So, but you see, I did not put negative here because cosine is an even function, sine is an odd function. Okay, so this is the trigonometric form of that vector. And then I can be told to write it in component form, then I multiply. Leave your answer to 3 decimal places, then multiply. But you have to remember that if the vector is in the 4th quadrant, then all students take calculus. Unit circle apply. The unit circle applies to vectors too. Okay, let's look for another one. One more, and then one more. Let's see if there's any one that looks like that again. Okay, I think we have done enough of that. Okay, so the next question is find the dot product. Use the dot product to see if two vectors are orthogonal. Okay, whenever you hear orthogonal, it means perpendicular. Orthogonal means perpendicular. Orthogonal, perpendicular. All right. If two vectors are perpendicular, their dot product is 0, perpendicular. If you ever find the dot product of two vectors and it's 0, the two vectors are perpendicular. In other words, the angle between them is 90 degrees. Okay, so let's go ahead and do number 11. So number 11, I want to find the dot product. Remember dot product, okay, I'm going to write it here. 1, 1. And then I can call this one vector u, and I call this one vector v is -1, 1. And that's a comma here. And I'm looking for dot product. I multiply. 1 multiply -1 is -1. No more vector parentheses. 1 multiply 1. And by the way, this should be plus. The dot product of a vector is a scalar. 1 multiply 1 is 1. Add these two together. -1 plus 1 is 0. Therefore, vector u dot v is orthogonal. Therefore, u dot v is orthogonal, perpendicular. U dot v is perpendicular because their dot product is 0. So whenever you're told to check and see if two vectors are perpendicular or orthogonal, it means find their dot product. If the dot product is 0, then they are perpendicular. Okay, let's see if we get another one. Okay, so you're going to see it in the test already. Check. All right, look at another one. Number 9 says determine whether the vectors are orthogonal. In other words, are they perpendicular? Let's find out. So I'm going to call this one vector u, call this one vector v. Is their dot product equal to 0? That's what I'm told to do now. So I am going to find the dot product. -2 multiply 2 is 4. -4, by the way. Plus -1 multiply -4 is +4. If I add them together, I have 0. So the two vectors are orthogonal. The two vectors are orthogonal. In other words, u dot v is 0. The two vectors are perpendicular. So it's not even a big deal. It's not even a big deal. All right. If two vectors, if you're told to write a vector in the form of ai plus bj, all you have to do is minus 4i. They are called position vectors. Minus 4i plus 17j, position vectors. If any vector sums up to 1, if the modulus or the absolute value comes up to 1, then it is a unit vector. So unit vector 1, 0, that is the simplest unit vector 1, 0. and 0, 1. Their modulus, the absolute value, their magnitude is 1. Okay, now we talked about orthogonal vectors. We talked about vectors in a Cartesian plane. All right, so we have already talked about some things. Vectors in a Cartesian plane. Write a vector in trigonometric form, change the trigonometric form to another form, and then you will be told to do that in a test. Okay, and then we're still in vectors. We are still in vectors. Well, let's find an angle between two vectors. We have find the angle between two vectors. Okay. All right. So let me see. Find the angle between two vectors. So number 5 and number let me see number 5 and let's see number 5. Find the angle between two vectors. All right. So the definition of angle between two vectors is u dot v is equal to the magnitude of u multiplied by magnitude of v cosine multiplied by cosine of theta. That is the definition of dot product anyway. So this is the definition of dot product. But when you're told to find the angle between two vectors, then you solve for cosine. So let me solve for cosine. So I'm solving for cosine theta. And now write u dot v divided by magnitude of u times magnitude of v. Okay. Okay, so I'm told to find the angle between these two vectors. I have to find u dot v in the numerator. But by the way, if u dot v is 0, then you don't need to continue. If u dot v is 0, you already know that the angle is 90 degrees. So let's go. Let's go ahead and find u dot v. So I will multiply from here immediately. So u dot v, -1 multiply -3. Okay, I have, let me write it this way, -1 multiply -3 plus 2 multiply 6. 2 multiply 6. So that is my numerator. And then, whenever I'm told to find the magnitude of a vector, it is just like find the, I'm going to x component squared plus y component squared right here. So this one is for u. Then I'm going to get the magnitude of v. The magnitude of v is -3 squared plus 6 squared. That is the magnitude of v. Okay, therefore cosine of the angle between them is what is there now. Okay, let me simplify the numerator. I already know that numerator is not equal to 0. So -1 multiply -3 is +3. So I'm going to write +3 here. +3. 2 times 6 is 12. All over. For this square root, I have -1 squared, that's 1, 2 squared. So here is going to be square root of 5. Square root of 5 multiply. This is 9. 3 times 3 is 9. 6 times 6 is 36. 36 plus 9 is 45. 45. And I hope you know that these are Okay, and I can write them in one square. So I have, in the numerator, I have 15 all over. So the angle is not 0. Angle is not 90 degrees because the numerator is not 0. Then the denominator. So I have square root of 5 multiply square root of 45. So I can pull up my calculator quickly. I'll pull my calculator up. Remember, I'm looking for the angle between these two vectors. So cos theta, angle between two vectors. All right, so I will just get my calculator and throw them in there. All right, so remember that the angle is going to be in degree. The first thing you want to do is make sure that your mode is in degree. I can't say it enough. You don't want to misattach that. Okay, so I am going to store my 15. I'm going to store this 15 in X. Makes my world easier. And then I'm going to maybe say divided by parenthesis square root of 5 square root of 5 okay, get out here. All right, so I'm going to say square root of 5 square root of 5 multiply square root of 45 square root of 45. And then I have an answer. And that answer is 15. The numerator is 15. The denominator is 15. Therefore, the cosine theta is equal to 1. Of course, you know, so I'm now going to find cosine, of 1. Okay, you don't even have to use your calculator. See, we know that in a unit circle, we want to find where cosine is. This angle is not 0. So it's not 90. So we come over here. We see cosine is 1 here, 1, 0. We know that this angle we're talking about is, we don't know where it is. Let me not say we know where it is. This one is 0, 1. The first coordinate is 1. This is negative 1, 0. This is 0, negative 1. Okay, and so cos inverse of 1 is 0. Therefore, the angle between them, let's just find it out, make sure. So the cos inverse is 0, but I just want to make sure that this is right. So we want to find the cos inverse. Cosine of 0 is 1. So cos inverse of 1 is equal to 0. So the angle between them is 0. Okay, they're not in a straight line though. There might be. Okay, so this is what we got in this. We're going to answer another question on angle between two vectors. Angle between two vectors. So let's go up and check where we see angle between two vectors. Angle between two vectors. So let me go down. We already talked about sine and cosine rules. So now we are working on vectors today. So looking for angle between two vectors. Okay. Find the angle around the, okay. I'm looking for angle between two vectors. All right, number 28 in this practice test. Number 28 in this practice test is asking us about angle between two vectors. So find the angle between two vectors to the nearest tenth of a degree. So you write the formula. Cosine theta, the angle between two vectors, is the dot product of the vectors divided by magnitude of the two vectors multiplied by each other. Dot product of the two vectors multiplied by magnitude of the first one times the magnitude of second one. So let's find the dot product first. So I'm going to multiply them immediately on the numerator. So I have -2 multiplied -1 is +2, okay, plus 5 multiplied -4 is -20. So I already know that